Hi, I'm Mike Hayes, and here's why this video is important. I'm going to explain why there's earthquake and volcanic activity throughout the western United States and how plate tectonics works, and also how you could eliminate the need for coal and nuclear powered electricity power plants throughout the western United States, and you would be able to replace them with geothermal power plants, and they could be built on the scale of those two previous items. The energy potential would not diminish. One of the criticisms of geothermal power is that if you go and drill into the earth and you set up a power plant, that the energy potential would diminish. Well, I will actually be able to show that this is not the case. I wanted to do this video now as an effort to raise public awareness of the dangers posed by these two things, earthquakes and volcanoes, and in some ways a little bit of thanks for the U.S. passing healthcare reform. I'm going to be able to get a heart surgery. A bit fatigued at times, stumbling a little bit here and there, and having a little hard time focusing. It's all thanks to my heart problem. And but I am doing a little fundraising as well. My fundraiser campaign is Heart Surgery for Mike Hayes. And also I have my website, westartpottery.com, and West Art Pottery on Etsy. Now, to get right into the subject matter here, the first image shows a very large blue arrow, and this is over a rift zone in western Wyoming. And there's this curvilinear pattern preceding it out to the west, and I'm going to explain why that is. The next diagram shows the rift zone, and more a depiction of the topography. The mountain ranges are depicted by the orange arrows. They're in a north-south pattern. The strata layers face each other. It's pretty much like two books raised up. And but along the central area, the pattern takes almost a 90-degree turn, and that's because the area is being stretched and sinking. And there's these two circled areas in blue, and those are sites of volcanic activity. There actually are more sites of volcanic activity within this stretched rift zone, and the reason why it's there, the rift, and also the volcanic sites and the stretching action going on, is because there's actually a magma flow traveling away from the Yellowstone hotspot between the asthenosphere and the lithosphere, or the upper crustal layer. And this is causing this geologic formation. There's actually two main sources of magma in the western United States. The Yellowstone hotspot, which is a magma vent. It's not like a mood lamp scenario. We have blobs coming up and creating volcanic eruptions. It's actually an ongoing, continuous flowing system. And when it reaches the lithosphere, it branches out in any number of directions. And I'm going to get to that in just a moment. I have these two illustrations that depict what's going on with this rift zone. You have the magma flow traveling underneath the central area of the rift zone. Have a little volcano depicted there. Very simplistic block fault mountains. The asthenosphere is somewhat, it's solid, but only so, because it's under such heat and pressure. It's something like wax in a way, and when you apply heat, even minor changes to it, it will expand and begin to flow around the magma flow, and it sets up this. It's like this. It basically jacks up the mountains, and like you get this buildup of almost like a paste-like consistency of aluminum oxide and SiO2 rock, basically, with some iron impurities and stuff. And this is what actually powers the plates of the lithosphere around. This is the central driving mechanism behind plate tectonics, because everything is energy based. I mean, there's a bit of gravity and density as far as like plates getting pulled down around subduction zones, but you need an actual high energy force driving the plates around the Earth. And this is how it works, because you have your central rift zones down the center, or throughout the ocean basins, and I can go on to explain that in more detail in more videos or articles when I get the chance. Now, this one that travels out of Idaho, or out of Wyoming, it ends up branching a little bit, and like in the case of, say, Park City and Alta, Utah, they had a number of mines, and those are actually centered around a volcano. The geothermal precipitation is what concentrated the metals enough where they could go in and mine. It was mentioned to me by a friend that there may actually even be some basaltic lava flows up there, up Guardsman Pass, a road that traverses from Big Cottonwood Canyon over to Park City. And also there are, of course, hot springs over in Midway, Utah. And actually one of these magma flows would travel underneath the Heber Valley, and this is what would be causing Mount Timpanogos to rise up. And the valley floor has also sunken over time. Oh, like in the diagram, what happens is when a magma flow travels underneath the crust, it also sinks, because the crust will actually begin to thin. You have like maybe slabs of rock material breaking off and being drawn into the flow. This would be indicated by 1 to 3.5 earthquakes. And also, like, and here's a picture of central Utah with a number of volcanoes. Very fluid magma has emerged out of these. So it would have to be, unlike Mount St. Helens, which was very thick, this is very fluid, hot magma. And let's see, you have a bunch of 1 to 3.5 earthquakes all up and down the central part of Utah. And of course, like, that flow could branch off. There's lava flows throughout Utah, from the north end all the way down the south end. I have this little picture of southern Utah. There's even a rift zone around Hurricane, Utah. There's a little volcano off to the right side of the image. I hope I'm getting my right and left here right. Which is actually just on the entrance to Zion Canyon. And of course there's volcanoes around St. George. There's even a spatter cone right within visual of I-15. You got volcanoes all around Las Vegas, one right near Henderson. And let's see here. Could cover the whole area, these little areas in more detail. Just want to kind of show these to kind of reinforce the notion that there's actually a lot of volcanic activity in the western United States. Here's a picture of Flagstaff. You got cinder cones all over the place. Some of these have fluid magma flows emerging from them. One of these came up in 1894. And Mount St. Helens, of course, was in 1982. That's only an 88-year time frame. given the number of cinder cones and volcanoes throughout the entire western United States, you could have volcanic activity in a time frame as brief as 100 years, whether it be a tiny little cinder cone, or even something a little bit more major, having magma just come to the surface and flow for months at a time, like Hawaii, which is another hot spot. Dilken here is an older formation, so they can perhaps start anew and diminish and move on. There's actually a number of sites throughout the Utah, Arizona, and New Mexico, and so forth, where there are, let's see, Moab, Monument Valley, the Henry Mountains. The San Rafael Swell would be something where, or a site where perhaps magma has entered into the crustal layers and has formed this blister formation. It basically appears just like a blister, when you look at it. And here's one of north central Colorado and just the southern edge of Wyoming. There would be a magma flow traveling through this area, and there's a bunch of volcanoes and other volcanic features throughout this whole area here. And of course, Steamboat Springs has plenty of hot springs. And here's Bend, Oregon. Plenty of cinder cones. Some take on a linear pattern, just like that asthenosphere depiction, or little chain depiction. You can kind of see the linear action there. And again, given the number of them, you could have, cinder cones pop up at any time. Okay, and returning back to this map of Yellowstone, it shows the blue arrows indicate just the general direction that the Yellowstone magma vent or hotspot has traveled over several million years. The network of red lines represent where these flows, in approximation, would be. Some, of course, have gone north, some, or many, of course, south. And there was also an 8.2 earthquake at Earthquake Lake. So there can be very large earthquakes set off by this system of magma flows rifting and sort of like stretching out the Intermountain West. Nevada has been stretched. This activity is actually continuing through eastern Utah and Colorado. So it's almost like the effect has traveled underneath and continues to do so. There could actually be one of these magma flows could have very well traveled all the way to Arkansas. There's an east-west rift zone through the northern part of Arkansas, and there are hot springs. There are cinder cones, even all the way down to the northeastern or the northwestern corner of Texas. And of course, there's a number of cinder cones in northeastern New Mexico. Some are old, some are new. And of course, there's magma flows even along the Colorado Front Range. And of course, there's the central rift zone down the middle of New Mexico, the Rio Grande rift zone, which also falls along the western edge of Texas. Sorry. Now, this depiction of California is one that sources off of Puerto Vallarta. There's actually a number of volcanoes and earthquakes that have occurred down that area, and the source of this magma flow could actually be back to all the way back to the Galapagos hotspot, but could actually source itself out of the Caribbean, It would travel under Mexico up through Baja, California. Under Death Valley, it would be the source of Mammoth Mountain, Mammoth Lakes. There's volcanic activity all throughout there. Lake Tahoe is only about 44,000 years old. The north end was sealed up by volcanoes. You travel northward, there's let's see, Mount Shasta, and it could very well branch at that point. Some going towards Oregon, central Oregon, and also out towards the Mendocino fracture zone. And there's a number of active volcanoes that, of course, go off or have gone off the coast of the Pacific Northwest. So anyway, to conclude, there's two main sources of magma underneath the western United States. One comes up the Gulf of California. The other one is the Yellowstone magma vent or hotspot. They cause the continental crust to spread, and the California one is what drives California northward by wedging it northward. And again, you can make donations to my heart surgery for Mike Hayes on fundraiser campaign. It'll help me cover this in greater detail as well. You could power the entire nation of Japan, electricity-wise, on geothermal power, because they also have one of these magma flows under their nation as well, and they wouldn't have to rely on natural gas imports and those nuclear power plants that they don't really like anyway. And it would also improve their economy because it would help their balance of trade, and perhaps even cut the cost of living. So it is important. Hope you enjoyed this. Recommend it to a friend. And also, let's see, always be prepared for earthquakes, natural disasters, and I think that pretty much covers it. Oh, and I got these little items on Etsy, and of course, I had my health problems, so I got to maintain it. But anyway, and don't port this to Facebook just yet. They don't have ad revenue. Hopefully, I'll get some funds that way. Hey, bye now.